what was happening in this world of management science was this guy, Thomas Sati, started to get interested in really big decisions. So a lot of the research that was done on decision making was done in economics and psychology and related disciplines, and a lot of it was fairly, you know, a lot of it was the lab experiments with psychology students and dealing with fairly small decisions. Sati was interested in the really big stuff. He was interested in how to, you know, can we improve the way that decisions are made that involve expenditures of, you know, millions or tens or hundreds of millions of dollars, or that involve decisions about whether to go to war, whether to establish diplomatic relations with a country, whether to support China entering the World Trade Organization was one that he worked on. These are big questions, and they're typically questions where you can, it's not generally too hard to triage the number of alternatives down to a pretty small number. Maybe often, sometimes just two, maybe two or three. What makes them hard is that there can be a very long list of possible consequences that you have to think about, of criteria for the decision. And often there are many stakeholders, decision makers, that need to have some sort of input into the decision. So that's what he was interested in, is can I come up with an improvement to the MCDM process, which had been around for a long time, come up with an improvement to it that will do a better job of decision making in those situations. So he, one thing that he realized is that when you look at the sorts of lists of preferences that people come up with for these big decisions, they typically are able to be categorized and subcategorized and sometimes sub-subcategorized. Okay, they lend themselves by their nature to categorization. And so that was an important insight. So then he started to think about, okay, how can I come up with a system where we can get 120 preferences and, you know, break those down into, I don't know, 20 categories, and then break the 20 categories down into another 6 categories, and then break those down into 3 or something like that. And that will make it kind of easier to handle. And then he got under the question of how do you weight these? And what he realized is that if he could come up with a way of rating preferences that produced ratio level weights or rates, then they could be combined by multiplication and addition. Okay, but he needed to come up with a way of getting ratio level weights. So that's where he got this comparative judgment idea from, which sometimes is called pairwise comparison, and there's a few other names that get used. So he did a lot of technical work on that, a lot of basically hard mathematics, linear algebra, and so on to establish how that worked. So this is really where the hierarchy comes into it. Is you have a hierarchy which at the top it has an objective, and then it has maybe several layers of categories of criteria, and then at the bottom you have comparative judgments of all of your alternatives on the bottom level of the criteria. Now let's have a look at some examples to see if we can make that a bit clearer. Okay, what I want to do first is just, I'm not going to do a hierarchy, much of a hierarchy here. I'm just going to show you just a simple hierarchy. This is a bit of a toy example, but I've actually seen exactly this technique used in market research. So imagine what we're trying to do is get some sort of ratings or weightings of preferences from people about their preferences for food ingredients. So the simple kind of standard way of doing this is you say to people, look, here's a bunch of food ingredients. 10 of them. I want you to rate them on a scale of 1 to 10, where 10 is your most preferred and 1 is your least preferred. And so your subject, your customer, whatever, sits down and they come up with a bunch of numbers, like the first column here. And, you know, for the purpose of aggregating them and reporting them, you may want to normalize them. So just this column here is just created by adding all of these numbers up and then dividing each number by the total. And that gives you a set of numbers that add up to 1. And then if you need to, you can produce a ranking. Okay. But depending on what you're doing, you may not need a ranking. It might be more useful for you just to have the numbers or the normalized rank. Now, this is a fairly standard way of doing things. One problem with it is, maybe the main problem, is trying to work out whether there's the measurement that's going on here is any good, whether it's good quality measurement. And what I mean by quality in this situation is, with this kind of rating information, it can be fairly hard to tell just with a simple thing like this. I can't look at that and tell you whether it's interval level or ordinal level or just noise. Okay. You might say, oh, well, it looks like it's at least ordinal because you can rank these numbers, but that doesn't actually make it ordinal. The person who completed this little questionnaire might have had very confused ideas about things, and those numbers may not really represent their preferences. They may not have been able to distinguish mentally in terms of preferences between 7, 8, and 10. You know, maybe their real preferences in the real world, in their own heads, doesn't really distinguish between those. And it might be if you gave them the same questionnaire a week later, they might come out with, you know, they might give cucumber 10 and, you know, beef and potato 8. And, you know, this gets down to this question of the reliability or the precision of measurement. So we have to be, if we get a lot of these, I mean, if I gave the questionnaire like that to a few hundred people and got the data, I can do analysis that will give me a pretty good idea of whether it's working as a measurement. But if you've only got a small number, no, you can't. So that was one of the problems that, you know, Sati was trying to address with comparative judgment. So the advantage of comparative judgment is the mental process that's involved is you're only looking at 2 things at a time. And what you're deciding is how much more you prefer one thing over another. Do you prefer it 3 times as much or 2 times as much or half as much? You're only making that one comparison. So the idea is that that's a much easier mental task, and that you're more likely to make a good quantitative judgment when you do that. And then you have this check once you finish the ratings in a set, in a comparative judgment set, then you have this consistency ratio, which gives some feedback about whether your judgments were actually sufficiently consistent to be decent measurement. So that's the thinking behind that. Now, the problem you get is, of course, this one of an explosion in numbers. So to rate those 10 food items there, you'd have to do 45 comparisons. And that's way beyond the capability of most people. Okay, I mean, they can do the 45 comparisons. What they can't do is 45 comparisons and get a consistency ratio less than 0.1. Okay, it's just too much to handle. So the solution to that is to see whether we can divide these into categories. So as you will see, I've taken the view that we can divide them into solid ingredients, starchy things, and protein sources. Okay, that's 3 categories. You might want to, you could possibly come up with other categories, you know, vegetables and non-vegetables or something, but that's one way of doing it. So what you do in an AHP process, if you've got a lot of preferences, you start off by you know, using the nominal group technique or something to brainstorm the preferences, and you maybe do some kind of voting like a board account to refine that a bit. But for a big decision, you might end up with still way too many preferences. And so then you look at whether you can categorize them. And you can often, in practice, when I've done this, when you're doing the plenary feedback session for the nominal group technique, you can actually do the categorization at the same time as you're writing them up on the whiteboard or whatever. You can start putting them into categories. Okay, so the solution, you create a hierarchy. So level 1 is kind of a formality. It's the objective of the thing. Now, this case we're looking at here is not really a decision. It's just about identifying preferred food types. Level 2 is the highest level category. So in this one, we've got categories of food ingredients. We've got 3 categories. We've got salad ingredients, starch, and protein. And so what we're going to do is a comparative judgment just of those 3 to decide the relative preference for those 3. And then the next level, level 3, that's the ingredients themselves. So tomatoes, cucumbers, lettuce, rice, potato, and so on. So what we would do is we do a comparative judgment there, and a comparative judgment there, and a comparative judgment there. So we've got to do, to work this out, we've got to do 4 comparative judgments, but each one has only 3 or 4 things to be compared in it. That's not a lot of comparisons. So I actually can't remember. I think I got these. I think I actually did this with a class of students once, and I averaged their answers, if I remember rightly. But anyway, it doesn't really matter where the numbers come from. So there you've got the salad ingredients, you've got a comparative judgment done, and you've got the scores, and we've got a nice low consistency ratio. And then the next one is the starchy stuff. Again, set of scores, nice low consistency ratio, same with the proteins. And then this is the higher level, the salad, starch, and protein level. And again, we've got the scores and a nice low consistency ratio. So once we've done all of that, we can do a weighted summary. So what you've got now, if you look at this, is you've got your 3 categories there: salad, starch, and protein. And so the categories have a weight. So salad ended up with 0.44, starch with 0.17, and protein with 0.39. And then you've got the weights for each ingredient within the category. Okay, so we've got tomato 0.08, cucumber 0.44, lettuce 0.49. So those ones, they add up to 1, and the category ones add up to 1 as well. Okay, so we've got all of those. And then to work out the combined weight, we just multiply. We multiply 0.44 by 0.08, that gives us 0.03. 0.44 by, what is it, 0.44 gives us 0.19, and so on. If you check that, you might find there's a few little rounding errors, but basically that will add up to 1. So that's a set of normalized ratio level weights for the ingredients. And then if you want to, you can rank them or whatever. So that's the simplest kind of case that we can come up with. So Mickey's asked us if AHP is a kind of MCDM. It is. So the most common way it's used is as a method for getting the weights for an MCDM, and if there are a small number of alternatives, for rating the alternatives. And we'll look at an example in a moment. But comparative judgment and the hierarchy thing can be used for other purposes. So this is an example where you might use it as some sort of market research for, I don't know, maybe if you were working for one of those companies like HelloFresh that does, you know, those packages of ingredients that you cook to make up a meal, you might use this as a kind of survey to try and find out what kind of ingredients people like to have in a meal. You know, you could use it for that sort of market research purpose. I've seen it. I mentioned in class, I had a student a couple of years ago, a master's student I supervised, who used it to develop a weighted index for regulatory breaches in a banking system. There were a whole long list of different types of breaches. I can't remember how many, but maybe 30 or 40 different types. And he was able to categorize them into a hierarchy. And then he did, he and some senior colleagues did comparative judgments to weight them. And so he was able to come up with a weighted index. So you can use it for other purposes, but it's most commonly used as an enhancement to standard MCDM. How do you get the category? Okay, we'll go back to that. Okay, so what we did, let me explain it again, because this is not usually very obvious in the first time around. Just tidy up a bit. Okay, so that's the first table there. That table there, this is kind of the, if you like, the simple old-fashioned way of doing it. What we do with AHP is we divide we create these categories. So we divide the food so that we can do comparative judgment. It's too hard to expect a customer or really anyone to do a comparative judgment of 10 things. Okay, that's 45 comparisons. So what we do is we look at these and we ask ourselves, can we find categories? And so I suggested 3 categories. Okay. So one is salad stuff. Oh, fish is in there. Hang on. How did that happen? Oh, sorry. I sorted the list. Sorry, I've sorted that list. Sorry, there's a category of salad stuff. So lettuce, cucumber, tomato. At least in my food culture, they are regarded as things you have in salads. And then there's protein sources. So there's fish, beef, pork, and meat substitute. And then there's starchy stuff, bread, potatoes, and rice. So they are 3 categories of ingredient. And so this is how we create an analytic hierarchy. So we have an objective at the top, and then we have these high-level categories. Okay, salad ingredients, starch, and protein. And then at the third level, we have the actual ingredients here, which fall under those categories. So this is a way of dividing the work up, if you like. And then what we've got to do to make all this work, we have to do a comparative judgment of these ones, of these high-level categories, to see how much. What this does is it works out what's our preference for salad ingredients compared to our preference for starchy things compared to our preference for protein. And then we do a comparative judgment for each of the things within each category. Okay, so that works out, do we prefer tomatoes over cucumbers or cucumbers over lettuce and so on. So there's 4 comparative judgments we do there. And then I've got just snapshots of the comparative judgment matrices there. That's the salads, that's the starch, the protein, and then finally well, I've got salad ingredients there. That should be categories. Okay, so that's our 3 categories. So this person prefers salad over starch, and salad over protein, and protein over starch. So once we've done that, then we can put it into a table. So we have this column here is the category weights. So just see it's salad is 0.44, so it's repeated 3 times there. Starch is 0.17, that's repeated 3 times. And then protein is 0.39, that's repeated 4 times. And then here you've got the results of the other three comparative judgments we did within the categories. So in this case, lettuce is slightly preferred over cucumber, which is greatly preferred over tomato, for example. And then to combine them, we multiply. So we multiply the category weight by the ingredient weight, and that then gives us a final combined weight for tomatoes. So 0.44 times 0.08 gives us about 0.03. So that's the combined weight for tomatoes. For cucumber, it's 0.44 times 0.44. That gives us 0.19, and so on. So all of these together, these combined weights, they will add up to 1. Okay, so that gives us, this is a normalized ratio level weighting for these things. Does that make it any clearer? I hope it's getting clearer, because we're now going to move on to a really big example. So the example that we're going to look at, it took me a while, quite a while actually, to find a real example that was kind of a big serious decision where I could get actual numbers. But I did find one. So this is an example. It's from the late 1980s. A Japanese company called Oki Electric Industry, they do a number of things. They're originally, I think, a telecommunications company, telephone manufacturing company, but they do all kinds of electronics. I think they do computer printers and so on. But at the time of this case, they had already had 2 semiconductor integrated circuit factories, and they needed to build a third one. And they had to find a site for this. So what they did, and it's a big decision. I mean, I couldn't find what it cost, but integrated circuit factories are normally very expensive. You're talking, I think these days, at least hundreds of millions to get a full-size one going. And they had some time to work on the decision. It was not a decision they had to make instantly. So what they did, the way they went about it was quite clever. You see this quite a lot with these kinds of decisions. They leaked to the media the fact that they were looking for a site. Okay, now if you follow the news, you will have seen that in the last few years, this has been done by Amazon, for example, and Tesla, and a number of those companies. And what they actually, the reason they do that is they want city governments to compete with each other to get the factory, to create employment and for status and so on. And city governments can offer things like cheap land and tax concessions and that sort of stuff. So this is pretty normal with big factories, is particularly in in countries that have fairly vibrant democracies where the city officials are elected. Companies will try and get the cities to compete with each other and to have a bit of an auction, really, to get the best deal. So what happened was they leaked it. It led to more than 20 city governments in Japan and from some other countries contacting them and expressing strong interest. So they had a fairly large project team, and they had various kinds of committees set up for consultation about this decision, and there were engineers involved and finance specialists and so on. So they got all these people. They did lots of consultation, and their first job was to triage this list of cities, of sites. And they did it with a table that looked something like this. So, well, almost exactly like this. The difference was their initial triage table actually had even more criteria in it, but this was what they'd got it down to in the final stage of the triage process. So what you see there is there's about, if we look at this one that's headed sub criteria, there are about 57 criteria there that were used for rating the cities, and they were rated on a very simple scale. They got an E, an F, an L, or a P. So E meant excellent, F meant fair as in meaning, you know, okay. L meant less than fair, and P meant poor. So they used that simple scale to eliminate all but 3 candidate sites. And in the notes there, I tell you where the sites were, but that's not particularly pertinent to what we're talking about. So 57 is a hell of a lot of criteria for rating purposes to get down to a final decision. They realized that this simple scheme was not really fine-grained enough, precise enough for such a big decision. So, and they were correct in that. There's actually enough information there. I was able to check whether that rating scale was very good as a measurement scale for close comparisons, and it's not. So the first thing they did once they got to this point, so they had Site A, Site B, Site C. They were all different. There were 3 different cities in Japan. One, if I remember rightly, one in the north, one in the centre, and one in the south. I think the southern one was on an island. So the first thing they do, quite a lot of these criteria, each of these 3 final sites had the same score. Okay, so for water supply quality and amount, they all scored E for excellent. So what they did was, and what I've done in the rightmost column there is I've just marked the ones that where they were all equal. So what they did was they discarded those criteria, okay, because they would make no difference to a decision. And so that reduced the table down to, that got it down to about 25 criteria. And I've set them up there as an analytic hierarchy. I didn't come up with the hierarchy, they did. So at the first level, you've got the top level, choosing the best site for the new factory. That's the objective of the decision. And then you've got the first level of criteria. So there are technical criteria, economic criteria, and social criteria. And then each of those has sub-criteria. So technical has the situation of the site, things about the actual piece of land, supporting industry, so things in the city or the local area that are needed for manufacturing integrated circuits, and then the weather. They include in the weather earthquakes and also corrosion from salt. On the economic side, they were left with a couple of things about the initial investment, so the cost of the real estate and the land, and the cost of, I presume that is installing electrical transmission lines. And then the stuff about traffic and the stuff about essentially labour costs and the availability of university graduates in the local area. And in the social stuff, what was left was some regional things about living expenses, absentee rates for some reason, something called transference. I couldn't find out what that was. I don't know. And then employees' housing, and then stuff about schools and medical services. So they were the remaining criteria for the decision. So what we do is just like we just did with the food ingredients, is you do a comparative judgment on this top level. So technical versus economic versus social. You do that comparative judgment. So you'd get 3 numbers, 1 for each of those, adding up to 1. And then within each of these top level criteria, you would do a comparative judgment between the components. So you'd compare situation of the site with supporting industries with weather, the relative importance of those 3. And then within each of these, you do a comparative judgment of their components. So there's 3 comparative judgments you need to do there. You know, is the availability of chemicals, more or less important than materials, more or less important than maintenance. That's essentially the idea. And then the final step is, on each of these, you would compare the 3 sites. Okay, so you'd have to do, you'd be doing quite a lot of comparisons. So, but they're not big numbers. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 25. So 35, 37, 37 comparative judgments to do. They wouldn't necessarily all be done by the same people. They might be done by people who are specialised in various ways. I might say something about that later, but the thing is, they didn't have to do this in a week. You know, they had months, maybe a year, to do all of this. This is a very big decision, so not something that had to be done overnight. So quite feasible to do it. Now, we can visualise it. I have this horrible diagram here, which took me half a day to create. And I only did it to just show what we mean by hierarchy here. So, so if you look at Sarti's books and papers, he tends to draw diagrams like this. So at the top level here, you've got choose the best site, and then that has 3 edges, we call them, coming out from it, those lines, and each one has a comparative judgment value. That's 0.7. That 0.7 there is for technical, and then you've got economic, that got 0.17, and social got 0.13, and then it just goes down the line. So if you go up to technical, that then has the situation of the site, supporting industries, and weather coming out of that, and then they have their comparative judgment values. Okay, and then we just keep going. So if we look at supporting industries, that's got 3 subcategories under it: chemicals, materials, and maintenance. And you have comparative judgment numbers here. So these are real comparative judgment numbers. I was able to get the actual CJ. Well, I was able to reverse engineer them. That's why this took me so long to draw. What I couldn't get was the comparative judgments for the sites. So I don't know what those numbers are, but that would be the last thing, is you'd have to, for each of these, you'd be doing a CJ for each of those. And then what you do to get the final weightings is you multiply through. You just multiply all these, follow the trail along the lines there all the way through down, multiplying the comparative judgments. Nobody does this in a tree diagram like that. Okay, you can do a T diagram for, you know, there's a certain kind of visual learner, and I'm one of them. I quite often will sketch tree diagrams to try and understand the structure of something. Other people find them totally useless and confusing, but in the world of management science, people use them a lot. What you actually do is you produce an MCDM matrix, something like this. Okay, so this contains exactly the same information. So I'll just make it a bit bigger, have a look at it. So here you've got, so this is like what we had before. You've got the objective, the high-level criteria, the sub-criteria, and the sub-sub-criteria. And then we start putting in the comparative judgment numbers. So what you have in this column, so in the stuff that's coloured this kind of yellowish colour, what we've got is the comparative judgment weight for technical. So that's 0.7. Okay, so that's just repeated as many times as we need to repeat it. And then here we've got economic, so that was 0.170, so that's repeated as many times as we need to repeat it. And then we do the same thing for social. And then the next set of numbers, this one here, this is for sub-criteria. So sub-criteria are these things here, like situation of site, supporting industries, and weather. So they get repeated here. Oops, so sub-criteria, so situation of site is there, and supporting industries is there, and so on. So you just got, these are all comparative judgment numbers. And then we get to the sub-criteria. So here we've got, this is where it's going to be a little hard to read on the screen. But for the, if we look at situation of site, we've got 3 sub-criteria there: area, environment, and approach roads. And those values are there. And the same pattern is just repeated all the way down. Okay, so we can see what's going on. Now, what this is all going to lead to is a combined weight for each of the sub-criteria. And that's what we use in the MCDM. So the MCDM calculation is going to be, you know, the rating for site A on the first one here, which is the area of the site. The weighting is going to be 0.29. And that 0.29 is calculated by multiplying 0.659 by 0.629 by 0.7.
Ed, I have a question.
Yeah.
So how do we know if a table is an MCDM decision matrix or AHP weighted summary?
The way you really would tell it, so the way to think about it, I think, is this. MCDM is any technique where you're going to be rating something on criteria, and the ratings are going to be weighted. Okay, so any MCDM is going to have, it's going to have this bit. It's going to have your alternatives across the top usually, and then it will have a set of weights, one weight for each criterion or consequence, or, you know, objective, whatever you want to call it. And there's some calculation then that is done, which is in the standard weighted additive model, is you multiply, you might put a rating in here, you multiply that by the weighting, and then you have another rating here and you multiply it by that weighting, and so on all the way down, and then you add them up, and that gives you a score for site A, and then you repeat it for site B and for site C, and the one that gets the highest score wins. What makes it AHP? Well, the first characteristic for AHP that you would look for is, how did you get the weightings? And if you got them using comparative judgment, then that most people would say that's AHP, even if there's no other hierarchy, because that technique is associated with AHP. Okay, so comparative judgment is just it's a way of rating things, but it's a way that is designed to automatically produce ratio level normalized ratings or weightings. So if we knew nothing else, we could use comparative judgment to come up with a set of weightings. And because we only have 3 sites, 3 alternatives here, you could use comparative judgment to do the ratings as well. The analytic hierarchy bit is all this stuff to the left here. This is where, given that we have a lot of criteria, we categorize them into a hierarchy, okay, a set of hierarchical categories, and then we do the comparative judgment on each level of the hierarchy, and then combine them by multiplying. Okay, that's the analytic. That's really the analytic hierarchy part of it. So I know it's a bit confusing. I mean, you could use, look, really my view is if you're just using comparative judgment, that's not really the analytic hierarchy process, because you're not doing anything that's hierarchical there. You're just using comparative judgment as a rating technique, and you can use that in lots of situations. It's a useful technique, but it has that limitation that once you get beyond about 7 or 8 things to compare, it just becomes infeasible for most people. And so then you have to resort, if you can, to this hierarchy thing to make the use of comparative judgment feasible. Does that make it any clearer?
Yep, thank you.
Yeah. I mean, lots of people use AHP with just small numbers of criteria, and they just use comparative judgment. You know, they call it AHP, and, you know, that's fine. It's just AHP with, you know, 2 levels or something. It's not, or 3 levels. It's not a more complicated one. I mean, I'll just say with this actual case, there's kind of a level in there that I didn't tell you about. So they had a lot of people doing these comparative judgments, and they found the geometric means of them, but they also weighted them according to the kind of person doing the comparative judgment. So engineers got a higher weighting than business managers, and they got a higher rating than factory managers. And they used comparative judgment to work out the weightings for those. So that's kind of, it's not quite another level in the thing, but it's a, you know, there's another level of, if you like, complexity or sophistication to this.
So Ed,
yeah.
You'd have to do this for each and every site, like A, B, and C. You'd have to do exactly the same process for each of the sites. So
what you do, the stuff that's coloured there, the stuff that's in colour, you only do once, because the end result of that is these numbers that I've called combined weight here. So you do that once, and then what you're going to be doing is, for each site, you're going to do a comparative judgment of A, B, and C using, okay, and then you will weight those numbers using this. So your comparative judgment on the first one is, what is it, the area of the site, I think, okay? So you would compare A, B, and C on the area of the site. I don't know exactly what they meant by area. It probably stands not just for the area in square meters, but probably something about the topography of the site and, you know, what sort of soil it's made of and whatever. But you'd compare the 3 on that, and that will give you 3 numbers that would go into these cells here. And then in your MCDM calculation, they would be weighted by this 0.29. Does that make sense?
Yep. So the 0.290 is the most important part of this criterion.
Yep. That is just these 3 here multiplied. So if you're doing this in practice, you know, your first step, if you're using it for a big decision, your first step is you've got to work out, you've got the triaging of the alternatives to do, and you've got to work out what the preferences are, or the criteria, I'll call them. Criteria are the consequences in the rational choice model, but people commonly call them criteria or objectives. So you've got to get this list here. You've got to get down to this list. But to produce these numbers, if it's a long list, you do this categorization thing so that you can do the comparative judgment here and the one here and then the one here, and that produces these 3 columns. So that's a preparatory process to then rating the sites on each of these lowest level, these sub criteria. So that's what you're rating your sites on. So for each site, you do for area, you do the comparative judgment. For environment, you do the comparative judgment, and so on. This is not something you do to decide what you're going to have for lunch. I mean, it's something you do for fairly large decisions, but by dividing the work up in this way, and if you can get it down to little groups of comparisons, 3 or 4 or something like that, that becomes a very manageable job. It involves probably a lot of meetings, or if you don't do it in meetings, you know, I mean, you can do it online. There's software you can get for this, but it's quite practical to do it. It actually makes the whole process fairly kind of organized, and it also means the process is very well documented. So if you've got to make a case, so one of the cases where this was used, an example I found, it was one I was originally going to use, but there wasn't enough information in it. So Sati was did a study of, so this was related to the entrance of China into the World Trade Organization, which was a big thing back in, I think it was about 2002 or something like that. It's a big international issue. And in the United States, there was a big debate about whether the US had this system every year of reevaluating China's status as a trading partner. And every year there had to be a law passed to reinstate China's status as a trading partner. It was a pain in the neck for the US and it was a pain in the neck for China. So there was a question about whether they should just permanently accept China as an acceptable trading partner rather than this process every year. And there were three kind of alternatives. I forget what they were exactly, but so Saaty did an AHP like this with a whole bunch of, influential decision makers around the place, and produced a very carefully documented report, which was then sent to members of Congress in the US before the vote on this. And the result of the process was a recommendation that this annual process should be done away with, and that's ultimately what the Congress decided to do. But there was a good example of something where you had a lot of stakeholders and experts, and there's quite a long list of consequences to the different alternatives. But by using the hierarchical process, stage by stage, so you start at, depending on what you're doing, you can decide whether you start at the high level here, or whether you start at the low level. But the thing is, it's a very systematic process for getting information that you need to make a decision, and doing it in a very well documented quantitative way. Okay, so I think I've created a bit of confusion about what an MCDM decision matrix is. So let me just go back and see if I can make it a little bit clearer. So all we mean by this is not a decision matrix unless you're deciding whether to, well, I suppose it is if you're deciding to choose something, but an ingredient. But a typical decision matrix, a simple one. So we've had lots of examples of these. Let me go back and find them. Okay. Oops. All right. So this is a really standard kind of decision matrix. Okay, MCDM matrix. So the ingredients, if you like, you've got some sort of criteria or objectives, a list of them. Okay. So that's what we've got there. And then you have, so they basically, from the pure rational choice perspective, they are the consequences. They encapsulate what we believe about the consequences of things. And then each one gets a weight. Okay, and that encapsulates the preferences or our belief about the importance of the consequences. And then you have a set of alternatives. I mean, the normal way of doing it is the alternatives go in the rows across the top. So we've got 5 alternatives there. So they're the things that make it a decision matrix. And then there is some calculation. So what you're doing is you're rating each alternative, each candidate here. Okay, so this is a staff selection example. You rate each candidate on each criterion. Okay, so this is a set of ratings, I think, that have to add up to 100 yet. You rate each candidate and then you multiply it by the weight and you add it up for each of the criterion. You just go down and add them up. And that gives you a score for the candidate. So candidate 1 ends up with a score of 14.3 there. So you do that for each of the candidates, and and then you can look at the ranking and you can decide, which is the best one. So
how did you get 14.3 for the first one?
Okay, well, it's 23 times 11% plus 5 times 14% plus 4 times 16%.
Oh, God, like that.
Like that, yeah.
Wow.
So there's a lovely little function in Excel called sum product that does all the dirty work for you there. So that calculation, that times that plus that times that, that's called the weighted additive model or the weighted sum model. That's the most common way people do MCDM. There's a whole bunch of other formulas you can use, but that's the most common one. But what makes it an MCDM matrix is not actually the formula. There needs to be a formula. Okay, that's essentially the formula, and the ranking is the decision rule. So you've got to have some kind of formula, and that one I just mentioned, the weighted additive one, is the most common one. But what makes it an MCDM matrix is that you have criteria, you have weights, you have alternatives, and you have ratings of the alternatives, and the final score that they get is some calculation based on the ratings and the weights. Okay, so they are the necessary conditions for something to be a decision matrix. AHP is all about how you get the weights. Okay, and it uses comparative judgment, and if there are lots of criteria, you will use some kind of hierarchy of criteria, which enables you to use comparative judgment. You can also, if you don't have too many alternatives, you can also use comparative judgment for the rating. That hasn't been done here. This is just one of those rating things where you say to people, assign 100 points to each candidate. But you could, if there are only a small number of alternatives, you could use comparative judgment for the ratings there as well. And that would be a good thing to do, but it's not essential. So the main game with analytic hierarchy is trying to do the best job of getting a good set of weightings, particularly when you have a very large number of criteria. Does that make it any clearer? So that's the bit that makes it MCDM. And so analytic hierarchy, so that's the bit. Think of it mainly as the analytic hierarchy process as being the bit that gets you a good set of weightings from a typically long set of criteria. That is most commonly used in conjunction with MCDM. But it can be used for other things like developing weighted indices of things, or there are a few other applications of it, but most commonly it's used for as one of the inputs, if you like, to MCDM. All right. Okay. So now, yep. So I'm sorry if it's a bit confusing. It's but I think that's probably the best way to think about it is the main problem that AHP was designed to deal with was one where you have complex decisions where there's lots and lots of criteria, and commonly lots of people whose preferences you want to aggregate. So what you do is you set up a hierarchy of criteria, and then you use comparative judgment. And if you've got lots of people doing comparative judgments, it's recommended you use the geometric mean to work out averages on them.